Testing. 1, 2. Alright. Let's begin. This is my solar electricity class paper, and it is on the Peltier Effect. Solar technologies are coming into their own these days. How we choose to apply the technology is entirely up to us. From using wind energy to move turbines to erecting solar panels to capture daylight, we have a lot of potential to create sustainable systems. I would like to explore every option to make sustainable energy useful and applicable. One application I would like to explore further is the use of the Peltier Effect to create affordable cooling for hot weather conditions. The Peltier Effect is named for the scientist that discovered it. The effect was discovered in 1834 by the French physicist Jean-Charles Anathies Peltier. Jean-Charles Anathies Peltier probably didn't know that he would be one of the first inventors of the refrigerator. Modern students are often introduced to Peltier as a physicist, but might be surprised to find that he didn't study physics until his retirement from the clock making business at age 30. But regardless of his experience in the field, the contributions he made to physics were immense. The Peltier Effect was an inadvertent discovery that Peltier made when he was investigating electricity. In an experiment that he would remember the rest of his life, Peltier joined copper wire and bismuth wire together and connected them to each other, then to a battery. When he switched the battery on, one of the junctions of the two wires got hot, while the other junction got cold. If the cold junction was put inside an insulated box, it would become a low-efficiency refrigerator. The Peltier Effect is sometimes coupled with its inverse called the Seebeck effect, and the two effects can be related to a third, the Thomson effect. Together, the Peltier, Seebeck, and Thomson effects are different components of the same scientific principle. In essence, the Peltier Effect shows that electricity can cause a heat difference at the junction of two different metals connected together. The application of this technology has been put into cooling CPUs inside of computers, creating portable miniature refrigerators, and cooling systems for electronic devices. Unfortunately, the heat exchange isn't the most efficient and therefore hasn't been applied towards larger systems like house air conditioning or vehicle air cooling. I would like to someday apply the Peltier Effect towards a vehicle air cooling system in tandem with a solar module, so that on the hottest sunny day, the cooling module would keep my vehicle's temperature nice and cool all day, no matter how hot it gets outside. Sounds pretty fantastic, doesn't it? You wouldn't have the need for dangerous gases like Freon or bulky compressors that use a lot of amps just to keep things cool. Now consider other ways this technology can be applied. One of the things science has discovered is that solar panels become more efficient in cooler temperatures. This being the case, wouldn't it be feasible if we could somehow use a Peltier Effect to cool solar panels during hot days to gain more efficiency? At this time, no applications of the Peltier Effect are being used with solar. However, everything that uses energy has a trade-off. Heat is a byproduct of electricity due to resistance in conductors. Harnessing heat is the easy part, but dissipating it is a challenge. The Peltier Effect has been replaced by other methods of heating and cooling for the same reason that it became popular to begin with. Although the process and utilization of the effect is simple, it is also inefficient. The Peltier effect dissipates quite a bit of heat, therefore using it in a practical manner involves finding a way to deal with the excess heat. Putting a fan in the cooler to carry the heat away is one of the popular means to make it more practical, but this can also be expensive to fix. A Peltier element has a number of disadvantages besides its inefficiency. It uses a lot of electricity and creates much more heat than it transports, which can easily lead to overheating if the extra heat isn't compensated for. Condensation is another potential dangerous problem with using the Peltier effect, occurring if components are cooled too much. This can lead to a short circuit between elements, which is never a good thing when you're dealing with electronics. All the negatives aside, the Peltier effect has a lot of technological potential. It is very reliable, and since it has no moving parts, it rarely needs maintenance. Contrary to other types of cooling systems, the Peltier method is easily transportable and affordable. Of course, John Peltier didn't know the true future of the physics behind his discovery, and likely didn't put as much thought into it as he did his other interests. The remainder of his life, Peltier studied other physical phenomena, including the high altitude boiling point of water and atmospheric electricity, among other things. I'm not sure what the best application of this technology would be, but it could be the next step to reducing our stress on the environment and our atmosphere by eliminating our dependence on harmful gases and wasteful technologies. Just imagine if you had, say, a hat with a solar cell that powered a small cooler in your hat. On the hottest days, you could keep your head cool and reduce the risk of heat stroke and exhaustion. Some people lack sweat glands and therefore have no natural way to cool their bodies without large, bulky equipment. A small vest with a Peltier cooler could serve as an option to those systems. There are individuals who do tinker with Peltier coolers and create small beverage coolers and fridges. If these ideas could be expanded and other uses could be devised, imagine, for example, using these coolers to condense water right out of the air itself. There would be no need to invest in expensive water treatment facilities or large irrigation systems. Instead, you could simply place a condenser over a reservoir or a well and irrigate crops and water livestock. It would no longer make irrigation dependent on large bodies of water and flowing rivers, which can become polluted and run dry. If electricity can be harnessed for free, then the cost of operating a condenser would be minimal. Just think of what it would be like if you not only got your water for free, but pre-cooled as well. How's that for a cool drink of water? As technology advances, we have the responsibility to use it to its maximum potential. Thank you for watching my presentation, and have a good day.